I were to take this triangle and copy it, these two are going to be congruent because they're the same shape, same size. Okay. And we'll know that they're the same size because the lines on the sides will indicate that they're the same length, and then we'll have angle loops to indicate that we have angles that are the same. Okay. Now if I take this triangle and this triangle, these are not congruent because they're not the same shape, nor are they the same size. Corresponding means to be in the same relative position. So if I have this triangle and this triangle, and let's say I rotate this one. This side will correspond to this side because they're in the same relative position, not in space, but in the triangles. Right? I have a short side, short side. The long side will correspond to the long side, and then the medium side will correspond to the medium side. So our sides will be in the same relative position. And then we have the same thing with angles. I'll just number these. Angle 1 will correspond to angle 1, 2 will correspond to 2, and 3 will correspond to 3. So they're not the same relative position in space, so the triangles can be rotated or flipped, things like that. But if you look at the shape of the figure, they'll be in the same position inside the figures, between the two figures. Does that make sense? Okay, so the two triangles are congruent if and only if the vertices can be matched in a way to where the measures of the angles and the lengths of the sides are equal. So this is like that other picture where I have equal side lengths and then equal angles. And then of course here you can see these are not congruent because they're not the same size, and they're probably not even the same shape. This angle looks bigger than that one.
Well, don't they have to give you those symbols for
You need to know the symbols for them to know for sure that they're congruent, or you have to measure everything. You have to measure every angle and measure every side length.
Like with what, like a contractor?
With a protractor and a ruler, yeah.
Can you do me a quick favor to do that next slide, please?
Sure thing. This is another way to represent the angles. Typically, I represent them with multiple loops because I think it's less confusing. But this one loop with 3 tick marks means the same thing as 3 loops. So if you see this or this, that's the same thing. Okay. ABC and JKL are congruent triangles, therefore the corresponding parts are congruent. Also, you'll notice A and J are the same angle and they're in the same position in the name. When we're talking about congruent figures, we have to put the congruent parts in the same order. So A and J are congruent, so they both came first. And then B and K are congruent, they both come second. And then C and L. Okay, so that's very important when you're talking about congruence. If I'm just naming any old triangle, it doesn't matter what order the letters come in, but if I'm talking about 2 triangles that I'm comparing, the congruent angles need to be in the same order. Does that make sense? Okay. And what we get is side AB is the same length as side JK also. And then side BC will be the same length as KL, and then AC will be the same as JL. So that tells us, by the letters being in the correct order, all of the parts that match. We are going to define the congruent triangles and then identify all of the corresponding parts that are congruent. It's the same picture. Okay, so A is the same as J. So I'm going to put A first and J first. B is the same as K. And C is the same as L. And then I put the symbol for congruent between them. So triangle ABC is congruent to triangle JKL. Angle A is congruent to angle J. Angle B is congruent to angle K. And angle C is congruent to angle L. Then I have side AB is congruent to side JK. Side BC is congruent to side KL. And side AC is congruent to side JL. Two ways to do this. If you're given just names, triangle DEF is congruent to triangle RST. And you're told to name the parts that are congruent. We can use the name, or we can draw a picture. Okay. Using the names, D goes to R, E goes with S,
Use a different color than the
green,
yeah.
and then F goes to T. Okay, so angle D is congruent to angle R, angle E is congruent to angle S, angle F is congruent to angle T, and then sides, I have DE, so RS, same position. EF, ST. And then DF, so first and last, RT. Okay, so we can do it that way where we just use the names. Or if you want, sketch out a real quick picture. And then you can name the sides that way. So again, angle D is the same as angle R, angle E is the same as angle F, angle F, sorry, F, I meant S. Angle F is the same as angle T, and then you can see the sides, DE, EF, and DF. Okay, so it's just a matter of preference. If you're more visual and the pictures help you to figure out which sides go together, then draw the pictures. If you can go with this names only, then just use the names. All right, if ABC is congruent to PQR, what angle is B congruent to? Q, yeah, because they're in the same position. And we could answer about angle A, angle C, we could answer angle P, angle R, side, AC, just anything like that, just from being in the same position. Any questions about that? Okay. If we have a triangle, ABC is congruent to UVW, U is 12 degrees, V is 49 degrees, and W is 119 degrees, what's C? Which one does C go with? goes with W. So angle C is 119 because it'll be the same as W. Okay, if these two triangles are congruent, what does X equal? Perfect. Okay, LK, now this one's a little tricky because the triangles are together and the picture can be confusing. This is a time when looking at just the names might help. Well, we went LK, so you want to go JN. You want the congruent parts to be in the same order. So JN. And then angle JMN, went JMN, would be the same as angle LJK. So we want to go in the same order. Does that make sense? Well, if they're giving us this one, we know JMN, so they went JMN like that. So we want to go LJK. You have to be in the same order. So whatever order they went in, you go in the same order. Just following the pattern. Yeah, following the order. If you want, you can take these pictures apart. You can draw J and M like that, and then you can draw another triangle and see how this is J and that's K. So that would make that L. And if that helps, you can do that. You don't necessarily need the picture. If the picture helps, use the picture. If the picture doesn't help, then don't use the picture. Does that make sense? Yeah, that's why I said it might help to take the picture apart if you can, but it's, for me, personally, it's just easier to use the names on this type of problem because the pictures are so tied together. Just using the names is more straightforward. So this one is more common sense than some of the other ones, but again, like I said, because this length is set, it dictates the angles. And to be congruent, you have to have 3 sides and 3 angles the same, but the fact that the 3 sides are the same forces the 3 angles to be the same.
So, like, if the sides are the same, that doesn't mean that the angles are going to be the same?
No, if all 3 sides are the same, then yes.
Okay.
But if only 2 sides are the same, we would need something else. So the first way you can tell for sure that triangles, 2 pairs of triangles are congruent if all 3 sides match. Now with all triangle congruence, you have to have 3 things that match. A minimum of 3 things. So the first one is all 3 sides, and then we'll get into the next one in a second. So SSS stands for side, 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 by the way. Not to be confused with SOS. Side angle. So that's angle, side, angle. So if I have some triangle, and I have another triangle, if 2 angles and the side in between them are congruent, and it has to go in that order, angle, side, angle, or you could go backwards, angle, side, angle. But you have 2 angles and the side between them matching between 2 pairs of between 2 triangles, then those triangles are congruent. So the first thing you need is either all 3 sides. The next thing you can have is an angle, side, angle. And the name ASA will always tell you the order the things need to go into. So this is 2 angles and the side between them. Okay. So far, okay? And the reason this works is because this side being in between the 2 angles, and then this angle opening as far as they are, it forces these sides to be the same length. So that's why that one works. side, angle, side. So again, I have two triangles, and we're forcing them to match. And so if I have a side, an angle, and a side. So this one is two sides and the angle between them. And the reason this one works is because if I have two sides that are the same length and an angle that's opening up, if the angle is the same between the two triangles, that third side can only be one length. Does that make sense? So that forces all three sides to be the same length, which forces all the angles to be the same, which forces the triangles to match. When you're identifying congruence, you look at what you have. I have two angles, and I have a side in between them. Angle, side, angle. So that's how those are congruent. Or I have three sides. So if I have three sides, it's side, side, side. Or I have two sides and an angle between them, and I have side, angle, side. Now, if I have two sides, I can only have side, angle, side, or side, side, side. So I'd need an angle in between or the third side. Okay? Angle, side, side does not exist as a congruence theorem. We don't have bad words in geometry. Okay? And it's not just that it doesn't exist because it's a bad word, like they didn't just decide, oh, we can't use that one because it's a bad word. No, it actually doesn't work. If I have an angle, let's say I have this angle and this angle, let's say those are the same, and this side length matches this side length, and this side length matches this side length. These two lengths can be the same, and this angle can be the same, but if this angle is different than this angle, I'm not going to get congruent triangles. It actually won't make congruent triangles to have angle side side. It doesn't work. It's not just that we're being prudish. Though we are. Don't cuss in geometry class. Okay, so this is never going to be, and you can't, also you don't go backwards. You don't have side side angle either. It doesn't, if you have two sides and an angle, the angle has to be in between the two sides or it won't work. Okay? A combined triangle. I want these two triangles to be congruent. I have this angle congruent to this angle. So I have an angle, and this side is congruent to itself. So in order for this side and this side to match, to give me side, angle, side, x would equal, thank you, 9.